All right. Well, welcome everybody out for the electrical workplace safety training, right? That we're calling it. Okay, so what we're going to do is we're going to go over, a lot of you have already been through this course, and there's some that probably should see this and will see this, that need to see it when they're in electrical panels and things like that. So a lot of this you've already seen, and I've actually cut this program down. I think the last time it was like an hour and a half or more, maybe 2 hours. So we've cut this down. We're going to try to trim it down to like 30 minutes or something. That's what we're going for. So we actually have some images in here. I don't know that anybody gets sick, but HR and Brandy and everybody warned us, so I have to warn you. We have some pictures that are a little graphic. Okay, so let's see if I can get this to work here.
An electric arc flash is a dangerous release of energy created by an electrical fault. And it contains thermal energy, molten metal, pressure waves, acoustical energy, and debris. When we talk about arc energy,
What happened?
in terms of calories per centimeter squared per second. A typical arc flash can release energy anywhere from a few calories up to 20, and exposures between 20 and 40 calories are not at all uncommon. Clothes made from cotton or polyester cotton or other everyday fabrics can readily be ignited at these exposure levels, and once ignited, they will continue to burn long after the arc flash is over, dramatically increasing both the extent and the severity of burn injury. The NFPA 70E standard applies to industrial electricians, not electric utilities. Because this hazard is lower voltage, people sometimes view it as less dangerous. However, it is absolutely not any less dangerous, even though the voltages are lower, the energies are as high or higher. And this standard...
Oh, dang it covered it up. So this is a 2-calorie arc. So the only reason that this is important is when you start getting into some of your arc flash ratings, you'll have a 12 or an arc rating on your gear that you wear that's all flame retardant or flame resistant. That'll have a tag on there. So that's why it's important to know that.
Over 1 million electrical workers in the United States. So we've undertaken this testing to create real-world arc flashes using common 480-volt electrical equipment to help companies better understand the magnitude of the arc flash hazard that exists in nearly every facility in the world. The things we learned by conducting this testing and sharing the video broadly clearly demonstrate.
See all that arc? This is all molten metal that's flying, and it's blast, and we'll talk about that here in just a minute. But anyways, we can go on to the next video just for the sake of time.
An industrial arc flash.
Let's see. Okay, so here's another video, and that one that we just watched was 480 volt. We have 480 everywhere. This building is actually supplied with 480. We transform it down to get some of the lower loads or the lower voltages that we need. But 480 is everywhere. All of our lift stations, all of our pumps for water, wastewater, we have it all over the place. So those arcs are a real hazard. We have that in our city or in our workplace. So here's another, I just thought we'd throw a couple of videos in here so you can kind of see what happens, and then we'll talk about it.
Talk about the honeydew list. This scenario, we have a little ladder inside of a house. It's happened many times. Someone going up, either clean the gutters, fix some flashing, whatever. Puts the ladder up right next to another end of their house, not realizing, caring what they're doing. They go up and get themselves in trouble. About 8 months ago, I was in North Brunswick. Just happened to check the job right back to the building. And I see extension ladder, 24-foot extension ladder, up like this. actually sitting on the primer as you paint the bridge. That was years ago. I'm pretty sure you can still. So stuff happens. I mean, it sounds kind of funny, but people aren't thinking what they're doing. They just get themselves in trouble. This is the worst case scenario. Ladder up on a primary.
So when he says primary voltage, that's probably 7,200 or higher. That's the basic, like 7,200 would be what the power company would call low voltage, or 4,600, somewhere in there. Most times around here it's 7,200 or more. Okay. Oh dang it! Oh dang it!
Talking about the honeydew list.
All right, never mind. Dang it! I rolled my mouse. I didn't realize I didn't move it. Anyways, it basically arcs between that ladder and the trailer because it's obviously grounded. A lot like this right here. So this, anybody ever seen a Jacob's ladder? Who's ever seen one? Nobody? Oh yeah, yeah, we've seen a couple. Okay, let me get on the other side of this. So let's see this. I just don't want to be near this side if I can help it. So this is 120 volt in, 15,000 out, and that's primary all over the place. Is 15 plus. You go up into the 500,000. See, this is only 15,000, but if we do this, put this in the middle of it, it immediately ignites that paper. I mean, it doesn't even take but just a second. And actually, I was doing it earlier, just messing around. I was showing somebody in here. You can see these little pinholes. That's the voltage actually going through the paper, burning it like instantly. And that because these arcs, I mean, these arcs are basically the surface of the sun. That's how hot it is. And so when something arc flashes, there's no time to react to any of this. And the amount of current and power, I mean, that isn't even if you get shocked. This is just, we're just talking arc flash. So this is like, when you weld, it's that flash. It's so hot. I mean, you can get, literally, you get sunburned off of it. And we'll show a couple of pictures on here. So basically what we're talking here is just don't put ladders, bucket trucks, we don't care if they're insulated or not. You don't want to be around any of this stuff. And even being within, like what this guy has here, if you're within proximity to that power, it'll jump. There's the donut that we always talk about, 10-foot, 20-foot radiuses, depending on the voltage. That arc will actually jump. You don't have to come in contact with it. This guy has a ladder that he's touching with it, which is obviously the worst case scenario. But I had another video that there was a guy that was doing siding, real life scenario, doing siding with a metal ladder. The ladder was an extension ladder going up to like the second or maybe even possibly into the third floor. And he just tipped it back and hit the power line. Obviously it killed him instantly, but probably burned the bottom of his shoes out and everything else. But this stuff happens all the time, and even though it's insulated, we never want to ever test that ability. We'll let them do that in the lab. We don't want to find out if that ladder really is good or not. Okay, so we're going to rattle off some real quick things that exist in electrical safety and the hazards that are present. So we have electrical hazards, and as we go through, you'll learn. I mean, obviously everybody knows that there's electrical here. We need to be careful, but we'll talk a little bit deeper than that. How to recognize the level of hazard, levels of personal protective equipment, how to work safely in proximity to energized electrical circuits. Really, if it's any kind of a panel, we don't want you working on it hot. We can shut it off. It doesn't matter what we have. In the city of Rexburg, we've deemed that there is no building, no process that cannot be shut down. We will shut it down, because if we don't shut it down and something arc flashes on it, like for example, wastewater has a 900 amp 480 volt service out there in the blower building. If that goes to ground and it arc flashes, it's like that video we showed a minute ago. It's a bad day. And it's even if you have PPE on, if you put, this is just a category, I believe this is a level 1, maybe even a 2. if you even had the highest category, which we'll show you in a minute, a level 4, you still come away with maybe a 2nd degree burn because they figure that's what's you can live through. But you don't want a 2nd degree burn even, obviously. So they basically are just saying everything that we do in all of this gear that we wear and everything else, you'll come away with maybe a 2nd degree burn or less. But we don't even want that. That's not a fun day either. So, and then obviously we want to be able to go home at the end of the day without any injuries. So we do have this safety program. We put this together. This is dated actually, and I updated some information I can send out to you. This was April 2012, but this is the electrical safety program that we've had in the city since then. We did it many years ago, and I've given copies of this to, I think Brandy has, she's not in here. I think Brandy has a copy of this, but we probably ought to distribute it to everybody. You can print it. It's not that thick, but it'll actually explain what we do in the city of Rexburg and the program that we have to make sure that everyone is safe. This is 70E. This is actually the handbook, so this is thicker than what 70E is, but it has a little more commentary and stuff like this. This is another book that we're going to be referencing throughout the program. This is what tells us what gear we wear, where we wear it, and to not get in panels if we don't have to, which in Rexburg there again we don't have to. Who's responsible enforcing workplace safety? Everyone. Private employers, federal employers, non-federal, and then there we are right here in the city. We're a part of it as well. Industrial Commission and Division of Building Safety, they're the ones that really drive it, but they've got the Idaho Safety and Health. Let's see, I can't remember what they call it. I think it's on the next slide. Anyways, it's the safety standard book, and it's very thick. You don't want a copy of that. But just know that we do enforce it, because a lot of people, like the word on the street is, oh yeah, if you work for the city or you work for federal government or you work for a governmental entity, then OSHA doesn't apply. Well, it doesn't, but it actually does, and we'll talk about that. All the departments are responsible for safety. Even those that are not in this training, we've polled everybody that we felt like would need to be in this training that are in it the most. Oh, I need to update this. We have more than 110. I don't know what we're up to now, but we're more than that, I think. 200 and something?
Sometime over 3.
Over 3, yeah. So NFPA 70E, that's the book I just showed you. That's the book that tells us what we have and as far as boundaries, arc flash values, and things like that. It's developed by NFPA. NFPA created they actually do the National Electrical Code. But with that, NFPA does it basically because if Congress did it, they would never get it through. That's the reality that we live in. NFPA has been brought through OSHA to say, here, create this standard so we don't have to have an act of Congress to change it whenever we want to change it. That's why NFPA and ICC exist today. The 70E is the how-to manual. It's basically talks about everything that we need to know about approach boundaries and things like that. Not directly adopted by OSHA, but it is in place in OSHA's standard of 1910-331. So it isn't directly, like I said, it would take too long to get anything passed if it was directly in Congress. So OSHA references the NFPA standards as their protocol of how to be safe. NFPA 70 is one of those standards, along with the NEC, and you have to remember the utilities, excuse me, I got a frog in my throat. The utilities use what we call the National Electrical Safety Standard, which is the NESC. We use the NEC. All of the public sector like us and homeowners and contractors, we use the NEC. It's a different standard, different rules, totally different all the way around. NFPA creates the NEC, but they also create 70E as part of that. So the NEC is NFPA 70. This is Electrical Workplace Safety, which is 70E. It's a consensus document from the industry standards. They've basically said, here's how to be safe when they created it. Not directly have we adopted it. This is the Idaho General Safety and Health Standards, which references the NFPA standards. This is the standard that I was telling you that's really thick, and you don't want to have to read it. 70E is one of those standards that's in the General Safety and Health, and there again, it's another consensus document, and this is the big thick book, and we just cut to the chase and go with 70E on electrical safety. Are Idaho employers required to follow this? Yes, we are. Both OSHA and Idaho Code require a safe workplace. There again, we've talked about that. Electric shock, arc flash, and arc blast are recognized hazards in 70E. And what is required by employers? So what is the city required to do? Employees must be trained. An electrical safety program must be developed and implemented. PPE must be provided. So here's one of the things that we get asked all the time, even out in the workforce. We have contractors that say, "Hey, who's supposed to buy this gear? Because this stuff isn't cheap. You know, this kit right here is really not that inclusive. Probably $500 or $600. If you go into a category 4, yeah, you're probably 5 times that. So who has to provide it? It actually is the contractor. So if it's XYZ Electric, they have to provide it. If it's the city, they have to provide it. So we have to provide it as a city, as an employer to the employee. And the reason being too is these gloves, these rubber gloves, they get pinholes in them, they have to be tested regularly. All this stuff wears out. And as it wears out, you don't want to find out that it's worn out and you shouldn't have used it. It should just be replaced. This is one of those things you have to be proactive, not reactive. Reactive, you're already burned and done. Now we're wondering why the glove wasn't replaced a year ago or 10 years ago or whatever. So the city has to provide that. So if you guys are in electrical panels and you don't have one of these, then it needs to be implemented and purchased. So we'll have to get this stuff if you don't have it, if you're in electrical panels at any point. Let's see. Arc flash hazards analysis conducted. We've been doing this on the new facilities as they're being built. The engineering that is provided with the project. So if we build a new building in wastewater, we build new buildings in water, we actually have them put these labels on there. And these labels are what tells us what the arc flash hazards are. And I'll show you one here in a minute. Let's see. So this is just an arc flash shock hazard label. This is just a general, there's live parts in here. This is the arc flash analysis that has been done. So 24-inch flash hazard boundary, 3-calorie flash hazard at 18 inches, and then all of the details, the date that it was done, the building, and what this is, the equipment name. And then if there's anything changed, transformers, anything that changes this value, it has to be reevaluated, obviously, because now it could be higher, could be lower, we don't know. So that's basically what the arc flash analysis would provide. Electrical hazards, we all know there's electric shock. I hear people say, oh yeah, he was electrocuted. Was he still walking? Yeah. Well, he wasn't electrocuted. Electrocuted, you're dead. It's done. You're pushing daisies up. Electric shock, okay, he got shocked, yep, or she got shocked or whatever. Yep, okay, yeah, they did get shocked. But if you got electrocuted, you're not with us. So, arc flash burns, arc blast. In fact, going back to burns comes to mind is, it isn't even just, you've got the arc flash burns and the arc blast, but what's around you? If you were out, say, on a pump or a pivot, or you were out, I don't know, maybe you were out in the field on a lift station and the weeds were 4 feet tall, and that arc flash happens, it flashes and burns you, so that bad day starts right there, and then it shoves you back into the weeds, and now the weeds are on fire, now we even have a bigger problem. And that actually has happened close to us. So, falls, so if you got blasted and fell off of, say, a ladder or whatever, that's another hazard there. I was going to show Jeremy this, because I was thinking, hey, maybe this is Jeremy right here. But he's not even in here, so he's going to have to watch it on the video. So, electric shock and burns, contact with energized circuit. So if you come in contact with an energized circuit, then you're going to have electric shock. Hopefully it's not bad enough, your shoes are insulated enough, and conditions are right where you don't get hurt bad. But holding onto a conductor that's energized doesn't necessarily give you the shock unless it has a path to go to through you. The problem is our heart is located as such in the middle of our chest to where if I grab onto something that's grounded and I touch something hot, where does that current go? Straight through my heart and through the chest cavity, and that's usually what happens. Is it burns you from the inside out, first of all, but it also stops your heart, throws you into some sort of arrhythmic heartbeat that now you're basically counting down to a fatality. Current through the body, as little as 100 milliamps is fatal. 100 milliamps is nothing. I mean, you figure like the breakers that we have in our houses and in this building, the smallest breaker we have in this building is a 20 amp breaker. That's 20 amp, not milliamp. That is 100 milliamp. So it's a fraction of what we're talking about with 20 amp. So GFCIs, like you have in your bathrooms and in your kitchens and things like that, those are a 4 to 6 milliamp threshold, 5 plus or minus 1. That's the standard that they list them to. What happens is they want to have that listed to a level to where if it detects anything 4 to 6 milliamp, it trips, and then it clears the shock hazard. So one thing I will say with that too, this is kind of more for in our buildings as well, but at home too. If you have an old freezer or an old fridge or something like that in your garage, and you plug it in and it immediately trips the GFCI, probably almost 100% chance you probably have a bad freezer or fridge, hermetic compressor, something like that that's actually creating a shock hazard. Back in the 70s, mid-70s, they came out with GFCI protection. And they came out with them, everybody hated them. Oh man, it just trips, it just trips. There was nuisance tripping. Nowadays, GFCIs are they're pretty solid for the most part. You'll get one or two here and there, but very few fail. So if you have something like that happening, I would take a meter. You can test it pretty easy. If your GFCI will hold long enough, you can throw a meter on that fridge into ground and see what it's pulling. And you're probably creating some voltage there. You are if it's tripping the GFCI for sure. So 30,000 non-fatal shocks annually, 1,000 fatalities annually. Oh, this is the graphic image. So I'll just kind of flip on through. That's actually a hand that grabbed the conductor, and it basically, he went to ground, and I don't know what the rest of him looks like, but it pretty well severed all 4 of his fingers. Electric shock, these are some of the injuries that come from it, and obviously none of these are anything desirable. Like the one that really is the one blast injuries, I mean, you get this, you inhale this, because what's the first thing that happens when you hear a loud noise? You inhale, and now you're inhaling all of that molten copper, aluminum, copper clad, I mean, all that stuff, and it's obviously way hotter than 98 degrees your body's at. So there's a lot of things that happen when these arc flashes occur. This is that sunburn that I was talking about. I mean, a severe sunburn. Up to 35,000 degrees. Look at the sun. I mean, it's crazy how hot this stuff is. So, how many of you guys have ever welded? I know you guys in the shop, I'm sure, have welded and you've actually got a sunburn on your arm. I mean, if you're not protecting your arms and things, it'll happen. That's the exact same thing as this, basically. Except this stuff is unintentional, and you're not thinking about it, and you can't close your eyes quick enough. Sometimes it'll actually burn your eyeball. It's that quick. And the thing that you have to think about is, do you think you could ever, if there was a piece of gear sitting right here, and I know it's not possible, but this is how you have to put it into reality. If there's a piece of gear sitting here and it arc flashes, you don't even have time to shut your eyes sometimes, let alone be enough away that it doesn't blast you. It's not possible. It's not humanly possible. So we just want to be careful and not have any of those injuries. So probability of surviving burns. This goes back to what I was saying, that you end up with a second degree burn. Second degree burn basically is just, okay, yeah, that sucks. I'm going to probably live through it, but it's not fun. So this is kind of the scale of how many percent of the body is burned and the survivability of it. You get up into any of this, and it's, I don't know. I think these are conservative, to be honest with you. But as you get above 80%, the survivability is just not good. Arc blast causes explosion, expansion of air and metal. Copper expands to 67,000 times what its original size was when it vaporizes. High pressure sound and shrapnel. That's the air that's faulting, arc flashing. And this is actually, and we'll show you at the end, this is a 40 cal suit right here. That's the highest that you can have. You don't get any higher than that. But even that, and that's with having, the other thing I forgot to talk about too, that's having a 40 cal suit on and he's getting arc flashed. But that's not having anything like spandex, polyesters, any of the synthetic materials underneath it. If those materials are underneath that and you don't have a cotton or a natural fiber, it will basically heat shrink to your body. And then when you pull it off, it pulls the skin with it. So it's not good. It basically, it's a heat shrink inside your body, even with that suit on. So you gotta make sure that you're wearing the proper gear. And that's why this presentation is a lot longer than this, is because we get more into those details. But really the moral story is you don't want to wear anything other than like natural fibers underneath this clothing in conjunction with these suits as well. Forms of arc flash energy. This is a big piece of MCC that failed right here. There's noise, expansion, vaporization, thermal radiation, and that's what this is. We've got eye protection. We've got there's my earplugs. So we have earplugs too. We have the rubber gloves that are worn inside the leather gloves. We have the balaclava right here. And then this is another important thing too. This is actually the face shield that you would wear as well. Like I said, this is I think this is a category, it's a 1 or 2, I can't remember. This is not a welding face shield. This is not a grinding face shield. If you use a welding or grinding face shield, it'll just heat shrink right to your face. So this is actually a different composite. It's not like a grinding face shield. So they're not even in the same category. Completely different composition of plastics. And here is flash of light is so intense it can damage the vision. I mean, even through your eyelids. It's just nasty stuff. You can see all the hair that's been singed off of his eyebrows or her eyebrows, whatever. Material molten metal can hit the body at over 700 miles an hour. That's how fast that stuff's flying. Like I said, there's no way you're going to get out of the way of it. Arc blast can cause inhalation injuries. For example, inhaling high temperature copper vapor. More than 100 toxic substances can be found in the fumes. That's all part of the paints and everything that they use to make these. The copper clad, all the stuff that comes off of it when it burns. The blast lung injury right here plus the burns is a greater chance of death. Obviously, you're inhaling that stuff. Then you end up with either pneumonia or infections, and it's just a bad day from there. Arc blast at 2 feet is 145. Jet engine is 132 at 200 feet. So this stuff is pretty dang loud. Pain threshold, it hurts your ears at 130. So, I mean, even by putting, if you figure an arc blast is 145, you put in like earplugs. I want to say they have a decimal, what do they call it? The decimal rating when it drops. It's a decimal rating of your hearing protection. and I want to say it's like 25 to 30. 30 is pretty high, so it's a noise reduction level. So if you took, let's say 30, and that's a high number, that's a very high number, 30 off of 145, it'll bring it down to basically 115. That's still loud as heck. I mean, 115 dB, this is, the jet engine at 200 feet is 132. It hurts at 130. So even with hearing protection, if you don't have hearing protection, there will be hearing loss in addition to all of that other stuff, too. So, pressure wave injuries, this is basically just the concussion of it, or the percussion of it, I guess you'd say. Arc blast can throw a worker off a ladder into nearby walls or equipment. 2,000 pounds per square foot. Pressure on the body can cause a concussion, collapsed lungs, and other internal injuries. And not to mention, there again, it's cooking you from the inside out. So when you throw a Hot Pocket or something in the microwave, the inside will a lot of times cook quicker than the outside. That's what it's basically doing. That's an electromagnetic wave that's heating your food. It's jiggling the water molecules and getting it hot, right? Well, what happens, the same thing with electrical, it's actually cooking you from the inside out, unfortunately. So whenever you get shocked or whatever, that shock will actually, it'll curl your nerve endings, and they don't grow back. It doesn't heal in those nerve endings either. So in addition to all that. So arc flash hazards, we've kind of gone through that pretty well. Arc flash hazard analysis, that's where we do the analysis, have an electrical engineer do the analysis and put the label on it. There it is again. And these are the boundaries. I don't want to get too deep into this because we're probably running pretty close right now, the time. But there's different boundaries for the different flash protection and how far out you are from the gear. Obviously, as you get further out, the lesser the hazard that exists. De-energized, the one thing I would say here, the only way you know anything's de-energized is if you throw a meter on it and you make sure that the meter is good before it. So go check that outlet, yep, there's 120. Go check that gear, yep, it's dead. There you go, then you know it's dead. Otherwise, you don't really know that meter's even working right. So, and I would get a good reputable meter. That's another thing that I would say if you're ever reading any kind of voltage. I know they sell this stuff at these cheap tool places. I would not buy one of those because personally, it's up to you. I would not buy one because I don't want that thing to blow up in my hand. I would get a decent meter if you're going to throw any kind of current or voltage on it. Electrical safe work condition, disconnected, locked out, tagged out. And everyone, I know Chuck and them have them. Jeremy has them. I know Alex has them. So we've got these things. Let's just use them. Make sure that they're locked out, tagged out, and make sure it's de-energized. Enclosed, yeah, we don't want to get too deep into any of this. Flame resistant, that's actually the FR clothing. And the reason that you'll ever know that you have FR clothing is because you paid a lot for it. That's the easiest way to know. Is this shirt that I'm wearing right here, maybe it's a $30 shirt, I don't know. If it was FR, it's probably 60 or 75. And so you know that it's FR. And if you see anyone, all the linemen for RMP, every single one of those guys, you'll notice they'll have a nice pair of Carhartts, they'll have an FR tag hanging out the side. Every one of those guys wear them. I notice it just because I always want to make sure. I'm like, hey, I wonder if they really do it. And I've never found one that hasn't had it. Let's see. Probably we'll rattle through this because we're getting pretty close, aren't we, on time? Okay, so, yeah, we haven't really rattled up. Qualified person, that definition is very, very, very open. A qualified person is someone that knows what they're doing. They know that they can get in this panel or not. They know the hazards. They know basically everything that is around it and how to avoid those hazards that exist. An unqualified person, obviously, is the opposite of that. And the employer, we're supposed to do what we talked about a minute ago. Yes. Responsibilities, just make sure you use all your PPE. It's no different than a harness if you're up in the air. Make sure you use it. CPR, do we have CPR? We've had it in the past. Do we have a lot in other departments? Do we have a lot of CPR trained people?
Trained people.
Mm-hmm.
I don't think officially trained. I mean, obviously we've got fire department.
Fire department, yeah.
But
Yeah, so it might not be a bad idea, I mean, to have people CPR trained in every department. All right, retraining, this is if somebody, is not complying, there's new technology that comes out, employee's not familiar with work practices, maybe a brand new employee or an employee that got new equipment, they don't know how to do it, how to run with it or whatever. Working on Energized stuff, this is what I talked about a minute ago. None of this stuff exists. It's feasible to shut it off. There's nothing that we have that is infeasible. In fact, there's even, I've probably told you this story before, but there was a guy presenting this class, and he said he went to a place back east, and it was one of these, it's where they do all the credit card transactions, and so it's one of the big hubs for credit card companies and all it's an economic thing more than anything. But they can't shut this down. He says, oh yeah, no, we're not shutting this down. This is like 20% of the United States currency runs through this as a credit card thing. And they said, okay, well, if we don't shut this off, here's what we'll do. They showed them the bill and they're like, oh yeah, when did you want that shut off? There's nowhere, anywhere that you can't shut this off. Because the problem is, if we don't shut it off, the cost of a life, yeah, you just don't put a price tag on that stuff. Oh yeah, well, we're going to have 20% of the United States currency not going through. Oh yeah, we don't want to pay that bill. Because the bill was millions. Because they knew that the people that had to go in there and service this stuff, if they had to do it live, they were going to have to do all these precautions to do it. And he said at the end of the day, they shut it off. It's done and done. And they obviously schedule those. They schedule the outage and everything like that. But they ended up making it to where they shut it off. So there's different voltages, there's different boundaries. We can go into all that deeper when we have a little bit longer class. There again, approach boundaries. I'm just going to kind of rattle through this stuff. These are the annexes in 70E. Those are hazard risk categories. Protective clothing. Yeah, so I think this is actually a category 2 suit because this is arc rating at 8 cal. And then there's the 4 down here. And that's a 40 cal suit, which we talked about. So here's an idea of what we're talking about with a calorie. It's 1.2 calories per centimeter squared. It's holding your finger in the blue part of the flame for 1 second. So that kind of gives you an idea if you just do the simple math of where that goes. This is a 40 cal, oh no, I'm sorry, that's an 11 cal right here. That's a 11 cal suit. Let me show you. So here's the typical PPE requirements. So this is 0, and then you just go over on the table. So a 4 would be a flash suit hood, including all of that on down. It's a lot of stuff. The other thing is when you put all this stuff on, the minute you get it all on, you're going to say, holy smokes, how am I going to even hold this screwdriver? You can't even do the job anyway. So just shut it off. Then you don't have to wear any of that stuff. You just get in there and do your thing, make sure it's de-energized before you do it, and it's done and done. So here's the thing that I was talking about. You don't want to wear any of this stuff because it's all basically heat shrink material. We use it to heat shrink wires, a lot of this stuff. So there's the flash hood that I talked about. It's not a grinding or welding hood by any means. There's the 40 cal right here. So can you imagine working, you can't even hardly see through that. Can you imagine working on that and trying to even put it in that outlet right there? It's not it just doesn't work. So here's some exercises. This is more for inspection, like where would we go if we had 240 volts and hazard risk categories and stuff like that. This one is actually an inspector, a state inspector that went on site. It was May 25th of 2010. That all this is there was an enclosure. Well, I think I have it right here. So this is a meter main up here, and they were junctioning it through. And if you'll notice, there's no screws in any of these. There's one right here, but none of this stuff is screwed in. And these wires had, this right here is where it arced, and right here. But what it did is they had like 1 or 2 wraps of some cheap electrical tape. And he pulled the cover to look in there, and then he's like, oh man, what am I gonna do? I gotta get this cover back on, or it's all exposed. So he went to put the cover back on, put his fingers down like this, and pushed the cover on, and it arced inside, and it burned his fingers like that, just that. Now, if you'll look, this is probably coming from the utility. I don't know, because I can't see it. I can't see really what's going on, but this is the meter side typically. So what this tells me is this is even a worse day because there's no breaker ahead of this. The breakers are in here. So if you pulled anything out of here, yeah, you'd have a 20 amp circuit. Right here, this is all at the mercy of the fuse in the transformer at the utility, which is huge. It'll burn right through that panel. Guaranteed. It won't even trip that fuse. In fact, he's lucky that's all that it was. That's a lucky day. But that didn't happen, even worse. And the electrician that did all this, he's no longer licensed in Idaho. It's done and done. They pulled his license. I was in the board meeting when they pulled it. It's bad. But anyways, here's some more arc flash burns. See this right here? That's a snake ready to bite right there. You go to put that cover on there, and that's a live conductor. And the thing that this looks like a mobile home panel to me. I'm not sure. I don't know where the picture was taken, but that thing, if you go to put that cover on, it's going to be a bad day. The good thing is if this is a mobile home panel, there's a pedestal sitting outside that has a 200 amp breaker. Still not good, but 200 is better than that fuse on that transformer of the utility. So anyways, there it is again. So so this is a category 2, the one that I'm talking about, or the one that I brought here. So there's a 40 cal, and there's the suit right there, or category 4, 40 cal suit. It can be hazardous, and you just want to know if you're going to get into this stuff, then let's have the conversation with 70E and look at what your hazards are. But at the end of the day, we want to go home uninjured. And that wraps us up. Do you have any questions? No questions?
Thanks.
Okay. All right. You guys are welcome to come up and check out the Jacob's Ladder too if you want. It's fun. Yeah. Yeah. Yeah.
If you haven't signed in, you better sign in or you won't get credit.